Hi all, I am Disha Shukla and welcome to the session. In this session, we are going to discuss about error compensation mechanism. Now, which error are we exactly talking about? See, when we come across different fading techniques like fading mechanism, that is whenever a signal travels through a long distance, there are possibilities that the strength of the signal may decrease. So we need to compensate these errors. For that, there are three different mechanisms. The first one is forward error correction, the next is adaptive equalization, and the third one is diversity techniques. So, what is forward error correction? Transmitters add error correcting codes to the data blocks. That is, code is a function of data bits. This has been added to the actual data block. So at the receiving side, you can compare the error correcting codes. If it's same, then there is no changes in the data. But if it differs, this means that the data has been changed. Receiver here calculates the error correcting codes from the incoming data bits. And again, as I said, that if it does not match, the receiver attempts to determine the bits in the error and correct the whole signal. The next type is adaptive equalization. It can be applied to the transmissions that carry analog or digital information. Analog voice or video or digital data can be adaptive equalization can be applied to both of them. It is used to combat the intersymbol interference. It involves gathering the dispersed symbol energy back into the original time interval. And the techniques used are lumped analog circuits and sophisticated digital signal processing algorithm. The third type is diversity techniques. Now, diversity techniques are the very important part in here because it is the main topic that helps in generating your the error generated codes into the original ones. So, diversity techniques for wireless communication. What is diversity? Diversity is a powerful communication technique that provides wireless link improvements at a relatively low cost. It provides two or more inputs at the receiver such that the fading phenomena among these inputs are uncorrelated. If one radio path undergoes deep fades, another independent path may have a strong signal at that point. The basic concept is that it transmits the signal via several independent diversity branches to get independent signal replicas. In other words, to have diversity, we need multiple branches, independent fading process branches to reduce the fading probability. Diversity schemes provide two or more inputs at the receiver such that the fading phenomena among these inputs are uncorrelated. If one radio path undergoes deep fade at a particular point in time, another independent or at least a highly uncorrelated path may have a strong signal at that point. If probability of a deep fade in one channel is P, then the probability for n channels would be Pn. So there are different diversity techniques for this. That is, the first one is space diversity. This technique involves physical transmission path. Next is the frequency diversity. In this technique, this is a technique where the signal is spread out over a large frequency band or carried on multiple frequency carriers. The next is time diversity. Time diversity techniques are aimed at spreading the data over time. The next type is that the diversity techniques are used to decrease the fading effect and improve the system performance. Now, instead of transmitting and receiving the desired signal through one channel, we obtain L copies of the desired signal through M different channels. The idea is that while some copies may undergo deep fades, others may not. We might still be able to obtain enough energy to make the correct decision at the transmitted symbols. Now, as I already said, these are the different types of diversity. Now, looking up for them in detail, the first one is frequency diversity. The diversity can be achieved by modulating the information signal through L different carrier frequencies. Each carrier should be separated from the other by at least the coherence bandwidth, that is delta Fc, so that the different copies of the signal undergo independent fading. These L independently faded copies are optimally combined at the receiver to construct the original signal. The optimal combiner is the maximum ratio combiner, which will be introduced later. Frequency diversity can also be used to combat frequency selective fading. The next type of diversity is time or temporal diversity. Now this is another approach to achieve diversity using transmitting the desired signals in L different periods of time. That is, each symbol is transmitted L times. The intervals between the transmission of the same symbol should be at least the coherence time, that is delta t, so that the different copies of the same symbol undergo independent fading. Optimal combining can also be obtained with the maximum ratio combiner. Here notice that sending the same symbol L times is applying the L once repetition code. Actually, non-trivial coding can also be used. Error control coding together with the interleaving can be an effective way to combat time selective fading. The next type is called the spatial or the space diversity. This diversity techniques use multiple antennas at the transmitting reception side. So L antennas to receive L copies of the transmitted signal. The antenna should be spaced far enough apart so that the different received copies of the signal undergo independent fading. This is different from the frequency diversity and temporal diversity. Here, no additional work is required on the transmission end and no additional bandwidth or transmission time is required. However, physical constraints may limit its application. The spatial diversity increases the signal to noise ratio, that is SNR. The next type of diversity is called the polarization diversity. In polarization diversity, the electric and the magnetic field of the signal that carries the information are modified and many such signals are used to send the same information. Thus, the orthogonal type of polarization is obtained. That is, whenever an electric signal and a magnetic signal that carries the information are modified such that both of them vary at 90 degrees, they are called orthogonal to each other. And this way polarization is obtained. The next diversity is called the angle diversity or the pattern diversity or the direction diversity. This diversity system needs a number of directional antennas. Those respond independently to the wave propagation. An antenna responds to a wave, propagates at a specific angle and receives a faded signal which is uncorrelated with other signals. The procedure to obtain angle diversity is to fix the antennas with narrow beam widths, different sectors in the system. Then the arriving multipaths from the different beam directions are resolved and combined advantageously. This process not only creates diversity but also increases the antenna gain and reduces the interference by providing angular discrimination. And the last type of diversity is called the antenna diversity. Antenna diversity is popular and extensively used technique to improve the performance in wireless communication. This technique reduces fast fading and interchannel interference effect in the wireless network system. In an antenna diversity system, two or more antennas are used and fixed in a position which will provide uncorrelated signal with the same power level. Then the signals are combined and created an improved signal. The basic method of antenna diversity is that the antennas experience different kind of signals because of individual channel conditions, and signals are correlated partially. So summing up the whole thing, there are many ways of achieving independent fading in a wireless system. One method is to use multiple transmit or receive antennas, also called the antenna arrays, where the elements of the array are separated in distance. This type of diversity is referred to as space diversity. Here note that with the receiver space diversity, independent fading paths are realized without any increase in the transmit signal power or bandwidth. Coherent combining of the diversity signals leads to an increase in signal to noise ratio at the receiving over the SNR that would be obtained with just a single receiving antenna. To obtain independent paths through transmitter space diversity, the transmit power must be divided into multiple antennas. Space diversity also requires the separation between the antennas be such that the fading amplitudes corresponding to each antenna is approximately independent. The second method of achieving diversity is to use either to transmit the antenna or receiver antenna with different polarization. There are two disadvantages of the polarization diversity. The first one is that you have to have at the most two diversity branches corresponding to two different polarization. And the second disadvantage is that the polarization diversity loses effectively half the power, since the transmit or the receive power is divided between two differently polarized antennas. Directional antennas provide angle or directional diversity by restricting the receive antenna beamwidth to a given angle. Smart antennas are the antenna arrays with adjustable phase at each antenna element. Such arrays form directional antennas that can be steered to the incoming angle of the strongest multipath combat. Frequency diversity is achieved by transmitting the same band narrow signal at different carrier frequency, where the carriers are separated by the coherence bandwidth of the channel. And time diversity is achieved by transmitting the same signal at different times, where the difference in time is greater than the channel coherence time, that is, the inverse of the channel Doppler speed. So this is all about what is diversity and what are the different types of diversity. If you have any queries, you can contact me. Until then, keep learning.